This is a kinematics reassessment. A ball is thrown horizontally at 15 meters per second from the top of the building, 140 meters tall. How far from the base of the building will the ball land? So these are the forces we know are acting on the ball. The 15 meters per second in the x direction and negative 9.8 meters per second in the y direction. So this is the picture of the ball getting thrown off the 140 meter building. We know it's getting thrown this way, again 15 meters per second, and we know it's coming down at negative 9.8 meters per second squared, but we need to know the distance from the building to where the ball lands. And that kind of spoiled it because I wrote it right there, but it's 80.25 meters. But let's talk about it. So in the vertical direction, we know the change in x is 140 meters. We know the acceleration is negative 9.8 meters per second squared. We know initial velocity is 0 meters per second, and we're looking for the time. And I spoiled it again. And in the horizontal direction, we know that velocity is 15 meters per second, and we're also going to look for the time for that one, and the time's the same because it takes the same amount of time for it to hit over here for both the vertical and horizontal directions. So what I did was I took this kinematic equation, change of x equals initial velocity times time plus 1/2 acceleration time squared. Plugged in what I knew. Then I solved and got negative 140 meters equals negative 4.9 meters per second squared times t squared. Solved for t, and that gave me 5.35 seconds. Then I took this equation, velocity equals change in x divided by change in time, and phone slipping, and I solved for change of x. So for my velocity I put 15 meters per second. For my time I put 5.35 seconds, and that left me with 80.25 meters. Seconds cancel out. So this is the distance that the ball will land in the x direction, 80.25 meters. And that's my kinematics reassessment. Let me know what you think.